Dear all, good morning. Now our lecture is eigenvalues and eigenvectors. In this lecture, we are going to discuss how to find eigenvalues and eigenvectors for a given square matrix. First, we discuss what is the definition of eigenvalues and eigenvectors. Definition: let A be a square matrix of order n, construct the homogeneous system of equations. X equal to lambda x, this one same as minus lambda I x equal to 0. Homogeneous system. The values of lambda, which system of linear equations has non-trivial solutions, are called eigenvalues. When the system equation has non-trivial solution, the lambda values are called eigenvalues, characteristic values. And the corresponding non-zero vector, this must be non-zero vector, are called the eigenvectors or characteristic vectors of A. Sometimes we can say the eigenvalues or characteristic values, invariant values or latent values. Also, this eigenvectors and characteristic vectors also called invariant vectors or latent vectors. The same word. Latent vectors, invariant vectors, characteristic vectors, all are same. Now here, this homogeneous equation has a non-trivial solution. What that means? A minus lambda I x equal to 0. Homogeneous equation has non-trivial solution. What the non-trivial solution means? Then the coefficient matrix. The coefficient matrix rank is A minus lambda I. The coefficient matrix A minus lambda I rank is less than n. The coefficient matrix rank is less than n. That is the coefficient matrix must be That is the coefficient matrix. That is A minus lambda I is must be singular. Rank is less than n means must be singular. Therefore, singular means the determinant of A minus lambda is 0. Suppose let A equal to n by n matrix. Suppose we are writing A11, A12 and so on A1n, A21, A22, A2n and so on AN1, AN2, ANN. Matrix. Alright, A minus lambda I is equal to 0. What the A minus lambda I is equal to 0 means? The determinant that implies A minus lambda I is the identity matrix. That means A minus lambda means only diagonal elements are subtracting with lambda. This one we can write A11 minus lambda, A12 and so on, A1n, A21, A22 minus lambda and so on, A2n and so on, AN1, AN2 and so on, ANN minus lambda equal to 0. This expansion we get some polynomial PA lambda with respect to A. We get this is minus 1 power n into lambda power n minus C1 lambda power n minus 1 plus C2 lambda power n minus 2. We get this alternative. At last we will get it depending on n, positive or negative, Cn equal to 0. This is the equation. Lambda means that is actually this is the a minus lambda. The same as we are writing p a lambda. The equation is called characteristic equation. Characteristic equation of a matrix A. Of the matrix, particular matrix of the matrix A. Of the matrix A. The roots lambda 1, lambda 2, lambda n. It is an nth degree polynomial. Its equation. Nth degree, how many roots? N roots. The roots are called roots of PA lambda. This is polynomial. Roots of this polynomial are called the eigenvalues. Eigenvalues of A. These are the roots of the polynomial eigenvalues. The equation is called characteristic equation. Now to find the roots, that are the eigenvalues. Now, suppose take this equation is 1. Now expand this one with a row or column. Suppose we are expanding this matrix, expanding, then we get a11 minus lambda into determinant. We are removing row and first column. We will get a22 minus lambda, a22, a23, and so on a2n. That means an1, an2, ann minus lambda. We will get this one minus a1 into. We get another. That means you remove second row, and second column. When you are removing this matrix, that means we are getting two lambdas are removed. That means we get lambda power n minus 2, n minus 2 degree, n minus 2 power, lambda power n minus 2 power. Plus again you can go for this a1 to a13, whatever you get equal to 0. That means we get all are lambda power n minus 2. Now similarly, if you go for this one a11 minus lambda, now again find the determinant. That means a22 minus lambda into, remove this row and this column. This one we get a33 minus lambda and so on. That means minus a23 into, you get this one. This is the lambda power n minus 3 power. Already one power is removed. Again powers are removed. Lambda power n minus 3 power. That means you are getting n minus 2 power n minus 3. Remaining all are n minus 2 n minus 3 powers. Now what I am saying, that means when you are expanding this one, only this diagonal elements. Next we are getting another diagonal element. Only the diagonal elements has power lambda power n and lambda power n minus 1. Implies we will get lambda power a11 minus lambda, a22 minus lambda, and so on, ann minus lambda minus lambda power n minus 2 power coefficient and so on, like that. See, equal to 0. Next to lambda minus 3 power, that alternative or minus whatever, we will get that one. Now in this one, what is the lambda power n coefficient? Yeah, coefficient of lambda power n equal to this coefficient of, we are getting coefficient of lambda power n only in this term of lambda power n in a11 minus lambda, a22 minus lambda, and so on, a minus lambda. So this is equal to what the coefficient of lambda power n. Lambda power n, when you are in this product, it means we get minus 1 power n only, minus 1 power n, minus 1 power n to lambda power n. Next to coefficient of lambda power n minus 1. This is equal to same as coefficient of lambda power n minus 1 in a11 minus lambda, a22 minus lambda, and so on, ann minus lambda. This coefficient. Now, what is the coefficient of lambda power n minus? When you are producting this one, getting this one coefficient lambda power n and the sum of a11 plus a22 and lambda power n minus 1. That means we are getting coefficient. This is a11 a22 plus up to so on an. Coefficient of lambda power n minus 1. Now, suppose let lambda 1, lambda 2, and so on, lambda n or n be eigenvalues of characteristic equation PA lambda equal to 0. The eigenvalues of this characteristic equation. The PA lambda means that is same A minus lambda or equation A minus lambda is equal to 0. Suppose I am taking this eigenvalues. That is the roots. Now these are roots. Eigenvalues are, you can say, roots. Yeah. Now what is the sum of roots? Sum of roots equal to lambda 1 plus lambda 2 plus and so on lambda n. Now observe here from 1, what are the sum of roots? That negative of coefficient of lambda power n minus 1 divided by highest degree coefficient. That minus of minus plus. That means we are getting that minus c1 minus of minus c1 equal to c1. Yeah, this is the coefficient of lambda power n. What is the lambda power n coefficient? Sorry, this is c1. C1 is the in this one. C1 the coefficient of lambda power n minus 1. What is the coefficient of lambda power n minus 1? Coefficient of lambda power n minus 1 is the a11 plus a22 plus and so on ann. That is sum of diagonal elements. What is the sum of diagonal elements is the, we know this trace of a. That means sum of roots same as the trace, and similarly product of roots and product of roots. Product of roots equal to lambda 1, lambda 2, lambda n. Now product of roots in this one, what is the product of roots from equation 1? Constant divided by highest degree coefficient. That is minus 1 power n cn divided by minus 1 power n. This is equal to cn. Now from equation 1, in equation 1 take lambda equal to 0. When you take lambda equal to 0 in equation 1, lambda equal to 0 means determinant of a equal to a. This is lambda 0. When the lambda 0, all elements are 0. That is only constant term. Each one is up to lambda degree. They all are zeros. Minus 1 power n. This is the 10. That is a positive number. That means we are getting in equation 1 take lambda equal to 0. We get determinant of a equal to cn. This is 2. From 2 to product of roots lambda 1 lambda to lambda n equal to Cn. This same as the determinant of A. Now observe here, the product of roots is the sum of diagonal elements. That's a trace. Product of the roots is the determinant. Therefore, or hence, that's the relation between. Hence, sum of roots, or you can say sum of eigenvalues. You can say sum of eigenvalues. The roots are sum of eigenvalues equal to case of A. Sum of eigenvalues is case of A, and product of eigenvalues is determinant of A. Now you can remember that any eigenvalues, the sum of eigenvalues must be case of matrix. Product of eigenvalues is determinant of A. Now we will see some example how to find this eigenvalues. Example: let A equal to 1, minus 1, 1, 1. You find the eigenvalues and the corresponding eigenvectors. Eigenvectors of A. Now find the eigenvalues and corresponding eigenvectors of A. Now solution. Yeah. To find the eigenvalues, roots of the characteristic equation. First write the characteristic equation. The characteristic equation of A is of A minus lambda is equal to 0. That implies A minus lambda, only diagonal elements, that is 1 minus lambda minus 1, 1, 1 minus lambda equal to 0. Equal to, now take this one determinant, 2 by 2 matrix determinant. So 1 minus lambda, 1 minus lambda square minus plus 1 equal to 0. Equal to lambda square minus 2 lambda plus 1 equal to 0. Now find the roots. Roots lambda equal to minus b 2 plus or minus root b square 4 minus 4ac 8. So that equal to 1 plus or minus 4, that's a 2i. That's I. 2 to can. That's a 1 plus or minus eigenvalues. Or you can find another way also. We know the sum of eigenvalues and the trace. That one we can write this one lambda square s of A plus determinant of A equal to 0. We get this characteristic equation. Lambda square. What is the trace of this eigenvalue? Trace of this matrix into lambda. 2 lambda plus determinant 1 plus 1. This is plus 2. Characteristic. You can write if it's by 2 matrix, you can write characteristic equation lambda square minus s of A into lambda plus mod A equal to 0. This is the one. Now the eigenvalue. Therefore, eigenvalues are of A are 1 plus I, and you can set lambda 1 equal to 1 plus I and lambda 2 equal to 1 minus I. You can take any one is first. 1 plus I and 1 minus I. Is it correct? Yeah. Now, so now find eigenvector. corresponding lambda 1 equal to 1 plus I. Eigenvector corresponding lambda 1. Eigen 1. See, what is the eigenvector? X is the eigenvector. A minus lambda. So 1 plus I. I equal to into x equal to 0. The same as a minus 1 plus. The A matrix is 1 minus 1, 1, 1. 1 minus 1. 1 minus 1 is 0. That I. That minus I minus 1. 1. 1 minus 1. That's minus I. Into x. Okay, x you can write x1. X equal to 0. Now solve this one. Now equal to 0. This one you can write minus I minus 1. Convert it to 0. Multiply I and add. Up and R2. I R2 plus R1. But I R2 plus R1 is 0. I R2. I into I square. Minus I square is I square is minus 1 plus 1. Plus 1 minus 1 0. This is 0. That implies minus ix1 plus minus x2 equal to 0. Equal to x2 equal to minus ix1. And therefore x equal to x1 x2. Sorry. x1 equal to x1 you can write x2 equal to x2 equal to minus ix1. That is x1 that's linear span 1 minus I. And therefore 1 comma minus I is eigenvector of A corresponding eigenvalue lambda equal to or lambda equal to 1 plus I or lambda 1. You mention or not, no problem. Eigenvalues this one. The next similarly find eigenvector corresponding lambda equal to 1 minus I. Corresponding lambda equal to I think 1 plus I. Yeah, 1 plus I, 1 minus I. Take it first one is take whatever first 1 minus I or 1 plus the one. Now A minus, we know this lambda I is x equal to 0. That implies A is the 1 minus 1, 1, 1. 1 minus 1, the minus is I. 1, I minus 1. This is 1 minus plus I into x1, x2 equal to 0. Now the same as you can write this one equal to 0. I minus 1, 0. x1, x2. What application require or apply R2. I R2 minus R1. I R2. I square. I into I square is minus 1. Minus or minus plus 0. This one. Okay, that implies ix1 minus x2 equal to 0. That means x2 equal to ix1. Therefore, x equal to x1, x2. x1 is x1, x2 is ix2. Previous what is the 1 minus I? Yeah. This is equal to x1 into 1 I. Therefore, 1 comma I is eigenvector vector of a corresponding eigenvalue lambda 2 equal to 1 minus I. Now you can write you can say this the tuple whatever this is eigenvalue and eigenvector. Suppose we write that 1 plus I. What is the corresponding eigenvector? 1 minus I, and this 1 minus I corresponding eigenvector is 1 I is eigenpair or eigenpairs. Eigenpairs of A. Whatever tuple eigenvalue and eigenvector, this is called eigenpair. And one more thing, the set of eigenvalues are called spectrum. Set of eigenvalues spectrum. Spectrum denoting set of all eigenvalues is called set of all eigenvalues is called spectrum. Spectrum. And it is denoted by sigma A or rho A. This is notation sigma. Okay, sigma A. Therefore, yeah, sigma A equal to set of all eigen. That means lambda belongs to that the eigenvalues are real numbers or complex number such that lambda p a lambda equal to 0. This is the one. Okay, this is the one. Spectrum. Now for this one, what is the spectrum of this matrix? For this one, spectrum of A is, for this example, spectrum of A is 1 plus I comma 1 minus I. Now you can write spectrum radius. Spectral radius. What is spectral radius? Okay, and it is denoted by rho A. So rho A equal to maximum of eigenvalue, maximal eigenvalue, such that the eigenvalue belongs to spectral sigma of A. But maximal length of eigenvalue is the spectral radius. This is maximal eigenvalue is the spectral radius. This is the one. Now see another example. Example 2. Example 2. Let A equal to all 1 1 1 1 1 1. Then find eigenvalues and corresponding eigenvectors of A. Now find this eigenvalues and solution. The characteristic equation. Equation of A is A minus lambda is equal to 0. This one is a 1 minus lambda 1 1 1 1 minus lambda 1 1 1 1 minus lambda equal to 0. So now any 3 by 3 matrix we get I give one formula for characteristic equation of any 3 by 3 matrix. Equation of 3 by 3 matrix will get lambda cube minus matrix A case of A into lambda square minus, suppose we take A is Aij. Now minus of diagonal elements one MII minus of diagonal matrix that MII minus plus minus this is lambda minus determinant of A equal to 0. This one it's give characteristic equation. Now observe here this one, this is lambda cube minus trace. This is the 3 lambda square minus it's plus minus of diagonal elements. First this diagonal. We remove this one, this 0. If you take this minor, this one minor, if you remove second row and second column, it's 0. The minus of diagonal elements only. This is diagonal elements minus. We get 0 into lambda. This is all are dependent columns. That is determinant is 0. That means lambda cube minus 3 lambda square equal to 0. That means lambda square into lambda minus 3 equal to 0. That means lambda equal to 0, 0, 3. Therefore, eigenvalues are lambda equal to 0, 0, 3. These are 3 eigenvalues. See, in nth order, we get n eigenvalues. Maybe some are repeat. One eigenvalue is repeat. Total 3 eigenvalues. Now, whatever this 3 by 3 matrix, suppose if we get n by n matrix, all each element is 1. Eigenvalues are 0, n. That means 0 is repeat n minus 1 times. Another eigenvalue is n. If 3 by 3 matrix, 0, 3. If it's a 4 by 4 matrix, 0 and 4. 0 repeating 3 times. If n by n matrix, 0, n. 0 repeating n minus 1 times. And another eigenvalue n. One eigenvalue is order of that matrix, another eigenvalue is zeros. The remaining eigenvalues are zeros. Lambda cube minus case of A into lambda square plus minus of diagonal elements into lambda minus determinant of A equal to 0. This one. And eigenvectors. Eigenvector corresponding eigenvalue lambda equal to 0. Now what that means A minus lambda I 0 into I is equal into x equal to 0. That implies that A is same 1 1 1 1 1 1 into x1 x2 x3 equal to 0. This all are dependent vector, the same as x1 plus x2 plus x3 equal to 0. Yeah, therefore x equal to x1 x2 x3 is equal to x1 you can write minus x2 minus x3 minus x2 minus x3 x2 x3 is equal to x2, if you take x2 common, minus 1 1 1 sorry minus 1 1 0 plus x3 common minus 1 0 1, where this x2 come x3 any real numbers, you can take whatever real numbers. Spanning action, this linear combination, these two are independent vector, the sum also independent vector, any linear combination. Previous also you can take this one, where x1 is any real number whatever you take, if you take scalar multiple again it's eigenvector. Any real number column. Therefore minus 1 1 0 transpose and minus 1 0 1 are eigenvectors of A corresponding lambda equal to 0. That corresponding lambda is 0. Now eigenvector corresponding second lambda corresponding eigenvalue lambda equal to 3. Now how to write this one? A minus lambda equal to 3. A minus 3 into I equal to 0. That implies we get 1 minus 2 1 1 1 minus 2 1 1 1 1 minus 2 into x1 x2 x3 0. Now use operations. This implies minus 2 1 1. Now convert this for zeros. Convert to echelon form. I mean apply an R2. R2 is R2 plus 2 R1. R3 is R3 plus 2 R1. Sorry. R1 plus 2R2 plus R1, 2R3 plus R1. Now multiply and add. Minus 4 plus 1. Minus 4 minus 3. 2 plus 1. 0. 2 plus 1. 3. Minus 2. Minus 4 plus 1. Minus 3. Next. Minus 2 1 1 0 0. Minus 3 3. x1 x2 x3 0. Now convert to this term is 0. Now add this 2 on up. R3 equal to R3 plus R2 0 0. That implies minus 2x1 plus x2 plus x3 equal to 0 and minus 3x2 plus 3x3 equal to 0. The same as x2 equal to x3. x2 equal to x3, that implies minus 2x1 plus 2 x2 equal to x3. x3 equal to 0. That means x1 equal to x3. And therefore x equal to x1 x2 x3. x1 is x1 equal, now write x1 equal to x3, x2 equal to x3, x3 is x3, x3 1 1 1. This x3 is any real number. And therefore 1 1 1 is on eigenvector of given matrix or of given matrix corresponding eigenvalue lambda equal to 3. Lambda equal to 3. Now eigenpairs are 0 comma 0 comma minus 1 1 0 transpose 0 comma minus 1 0 1 transpose and 3 comma 1 1 1 transpose or eigenpairs. Now observe here. Now we got eigenvalues are, what are the trace of this one? 3. That's a trace 3. Determinant is 0. That's a sum of eigenvalues is 3. Determinant is 0. Now previous example also you can observe eigenvalues are Yeah, plus or 1 plus I minus I. What that trace? This one 2. Now add 1 plus I and 1 minus I. We get 2. That's trace. Now determinant is 2. Now take 1 plus I into 1 minus I. Yeah, that is a plus b into a. That is 1 square minus I square. That's a plus 1. This is 2. Mention product of eigenvalues is the determinant. Sum of eigenvalues is the trace. Now this one. What the spectrum is? Spectrum. What the spectrum? Sum of a equal to 0, comma 3. Only 2. And spectral radius equal to maximum absolute value of maximum value. This is spectral radius. This is the one.